Next, we'll talk about rates of change, which is a huge theme in calculus. You can think of a rate of change as a speed. For example, the familiar speed unit, miles per hour, measures the rate of change of distance with respect to time. In other words, rate of change of miles with respect to hours. We will see that the rate of change on a graph is given by the slope of a line. For example, a car on a freeway passes mile marker 20 and travels at 60 miles per hour until it reaches mile marker 80 1 hour later. Graph the car's distance traveled versus time and find the slope of the line. We're going to put distance on our vertical axis. We're measuring that in miles. Let's use units of 10 miles here. So we'll mark our vertical axis from 10 to 80. And we're going to put time on the horizontal axis, and we're measuring that in hours. And I'm going to put the 1 hour mark over here on the right. Notice that's the sixth mark. 1, 2, 3, 4, 5, 6. So that means that each of these marks is a sixth of an hour. In other words, 10 minutes. So this mark here would be at 10 minutes. The next mark would be at 20 minutes, etc., until we get over to 60 minutes, which is 1 hour. The very first thing the example says is that the car passes mile marker 20. Now, it doesn't say when this happens, but since that's the first thing that's happening, let's say this is the start of our graph. In other words, at time 0 hours. So at 0 hours, I've got to mark it 20 miles. Now, since it's a little easier to think in terms of minutes, even though our x-axis is technically in hours, let me point out that 60 miles per hour is the same thing as 1 mile per minute. And maybe I can convince you of that by doing a quick unit change here. There's 1 hour for every 60 minutes. The hours cancel out, leaving miles per minute, and 60 over 60 is 1. So we have 1 mile per minute. And that makes sense, right? Because if you're going 1 mile every minute, then in 1 hour, 60 minutes, you've gone 60 miles, hence 60 miles an hour. So in 10 minutes, we'll have gone 10 miles. So I can put a dot at the 10-minute mark, which is the same thing as 1/6 of an hour, up at 30 miles. And every next sixth of an hour, in other words, every next 10 minutes, we go 10 more miles until the end of the problem after 1 hour, where we've reached the 80-mile mark. So there's a graph of miles versus hours. What's the slope of that graph? Well, using rise over run, I've got a rise of 60 miles, right, going from 20 up to 80. And I've got a run of 1 hour, going from 0 hours to 1 hour. So the slope is 60, and notice that gives us our units, miles per hour. So when you graph miles versus hours, the slope of that line gives you the rate of change of miles with respect to hours.